Good afternoon and a good morning to a couple of you, and welcome to today's webinar sponsored by X-Rite and Pantone. Before we begin, I would like to go over a couple of things, a few housekeeping points. Because of the amount of people that we have during the webinar, we will keep everybody in mute. But if during the webinar you have any questions that you want to raise to Dan, you can type in the questions function from GoToWebinar. I will be monitoring the questions, and towards the end of the webinar, we will have time for a short Q&A. And finally, this webinar is actually being recorded, as well as the other versions of this webinar series that we have. So you will be receiving at the end of the webinar a link that you can, when you want, you can review the webinar. So again, welcome to today's webinar. We will be discussing color management for grand format printers. As I mentioned, this is a webinar, the last webinar of a series of 3. My name is Paula Rosales, and I'm the marketing manager for print and packaging for X-Rite in Europe, and I will be moderating today's webinar. X-Rite is the global leader in color for those of you who know us. We have Pantone as part of the X-Rite family. This has been since 2007. So we gather and have a lot of products for the printing industry markets, very mature, especially for the commercial print. But obviously, as the needs for the markets change, also we have been introducing products for that are good for the grand format printer. Today with us, we have Dan Reid. Dan has been for more than 15 years consultant and providing color management consultancy services to many leading brands and printing service providers. He's also G7 certified since 2006, so he's an early adopter of the G7 and has been helping numerous businesses to achieve merits of G7 and help them with all of their color management workflow issues or challenges that they have. Dan's company helps business maximize their profits potential and decrease the waste by improving efficiencies and repeatability for commercial trade and grand format printing customers. Dan, welcome to today's webinar, and thank you for these 3 great webinars or 2 great webinars that we have and this upcoming webinar.
Thanks, Paula. Good morning, everybody. Thanks for joining this webinar. As Paula said, this is going to be recorded and shared later on. We did that for the first webinar, which was on printer calibration, and it's available at this web address. Paula may post that into the chat window later on, but you will see links to the first webinar as well as the second webinar that we did that was on G7. So that was a very popular webinar, and we will be sharing that link. Here is a bit.ly link if you want to write that down, or it may show up in the chat. So first off, I want to kind of launch our first poll question so I can get a sense of who's on the call today. Paula, could you launch the first poll, please?
Yes, it would be great if all of you could start posting all of your information. That would be great. So I start seeing some of the results already. Okay. Perfect. So Dan, we have 50% of the customers says that the biggest challenge is the supplied files from their customers, and 50% actually the named colors, the PMS or brand colors.
Okay. So files that are supplied and named colors like the PMS colors. Okay, well, that's good. So let's launch our second follow-up question to that, which is, why is this so difficult?
again, it would be great if you could take part on this last poll from today. Okay, so I see the results we have also 50% say that they're not sure, and 50% actually says that it is too expensive, the extra software and hardware required for this.
Okay, good. Great. Thanks, Paula. Well, that gives me a little bit of a jumping board because we are going to address how PMS colors are coming into shops, being designated properly or incorrectly, how to deal with CMYK and RGB files, and what is the merit of putting an investment in this. So let's kind of jump into it. So first off, I want to kind of start with like a kind of a brief breakdown of the history of kind of color communication. That's what I like to call it. Printing has always been a challenge. It's never been exactly easy, but actually we're doing better than we have in decades earlier. The expectation level is much higher than it was, where you have much better quality printing. And so, we're able to quantify even better how good of a color match we have before we actually even go and print it. So we have the ability of kind of, if not pre-flighting the color to see if that's going to work on that particular machine and substrate. And traditionally, we've kind of looked at this more of a mechanical thing as saying how much density or what the dot gain would be, and if we got those to match, theoretically, we would have a visual match. But I think a lot of people have experienced that that is not the case. And so when we moved into 21st century here, we now are using fancy measurement devices that kind of look at the color, not so much of the mechanics of the printing. So one of the early systems, and actually there was an interesting tweet just recently about a early PMS system that predates Pantones by several hundred years, but one of the more ubiquitous ones is the Pantone matching system. Everyone has seen this. And this was born out of frustration from printers back in the 60s of trying to communicate what cosmetics and automobile and certain brand colors would look like in printing. And Pantone actually was a company that was a printer, and they evolved into now the company that you know today, but originally they started off as a printer. And as they kind of have evolved over the decades, or rather printing technology has evolved over the decades, so has their Pantone matching system. So even in the last 10 to 20 years, we've had multiple updates to those guides, which is good because we're not using film any longer. We're printing directly computer to plate, and then now in grand format there is a completely different printing system. So it's good that they keep on updating it. The downside is that there's so many versions, it's a pretty good chance that the version that's in your hand may not be the version that's actually loaded up in your Adobe application or in your RIP. Meaning that the swatch book that you have may be a couple years old, but your RIP that you just purchased or the new Adobe CS library has actually the latest versions that don't correspond to your color guidebook. Now, there are ways to kind of load in older versions, but you got to be careful because your clients are going to be submitting jobs potentially with new versions. So this creates a whole bit of mess of which is the correct version. Is it the version that the customer sends, or is it the version that you have in your hand at beside the printer? Now, the CMYK builds that are listed in these books are helpful, but they're only so helpful, meaning that their CMYK builds are designed for a lithographic press, and they're designed for a particular type of printing. And those CMYK builds probably are not going to work for your printing technology just because it's not lithographic. So I would throw an air of caution of using those CMYK builds without color managing them to your output device. But the best way of kind of doing this is to kind of get a lab specification. And lab is just a color model that is agnostic to printing technology or RGB or CMYK. It's based upon how humans respond to color. So if we can get the specification as LAB, we have a better chance to translate that into our printing process. So I recommend measuring color books if that's something that you have the gold standard. You can do this very easily and then find out what the CMYK build needs to be for your particular color book. There is other ways of just pulling the lab directly from Adobe CS if you have a true solid color and not a process build. So process build is the one where you see the CMYK numbers and they won't actually show you a lab definition on that. So you kind of are locked to just using the solid colors. But if you have a CMYK build that is a process color and you need to match that, you can use a spectrometer to ascertain what that lab value is to give you the correct value that you need to use for your printing technology. So you might consider getting a newer fan book if yours is a couple years old, because again, the Adobe CS libraries are going to be different than potentially the book that you have in your hand. And you're going to have a whole problem of trying to find out why the separations that are being created in Photoshop are not correlating to the fan book that you have in your hand. For a while now, XRite has been shipping a software called the Pantone Color Manager. It's actually included with XRite EyeOne products. It is a product that you can purchase separately, but basically it is a product that allows you to kind of synchronize all your Adobe apps with the current fan book references. Now notice I kind of underlined the current there, because that's what they want you to do, is obviously have the latest book. If you have older books, you can go and download the older libraries from Pantone and load them up. But again, you got to be a caveat there, knowing that some of your customers, or most of your customers, may be sending in documents that have the newer references. So you got to be very, very careful on how you handle your Pantone colors. But this application is pretty cool. It does more than just kind of synchronizing. It allows you to kind of extract colors from images. I have one client that has taken their complete image database, and we're talking at least 100,000, if not more, images. I mean, it's a massive database, and they have run it through this software to create a color palette of each image. So a designer can search for imagery based upon colors. And it's an interesting use of this Pantone Color Manager, but they find it's very, very useful for their clients, where they can now search for particular colors and find imagery based upon that. You can use some of the colors from images to build out special colors for your ICC profiles. You can use it for optimization techniques. It's really an interesting product that is not really talked about a lot. I would definitely consider looking at it a little closer if you have not done so up to this point. And so here's a picture of, rather some screen captures of how the Pantone Color Manager works. You can see here on the left-hand side that we've selected a particular coded process color. And it says, okay, well, here's what the color is if you wanted it as sRGB, and if you were using a sheet-fed coded profile, here is what the CMYK values are. Now, you see on the bottom there, you have the ability of switching from US sheet-fed coded in the pull-down menu to a different profile. So you would more than likely want to be loading up your custom profile that you made for your printing conditions to find out what the CMYK build needs to be for that particular color. On the right-hand side, you can see that we've extracted some colors. Again, it's a Pantone Cool Gray, and they give you some numbers there that are based upon Grackle down there on the bottom. So why can't I just use a densitometer? You know, An X-Rite 530 is actually a spectral densitometer, so it gives spectral readings and lab in addition to densitometry, whereas the EyeOne Pro 2 is just a spectrophotometer that you can derive density, but it doesn't report density normally. So when you're using a densitometer, what happens is it just is measuring for that particular color what is the ink film thickness or how much ink is piled onto the paper. It's not so concerned of what the color of that cyan is, of that cyan ink is. It's just concerned of how much ink is on that paper. And I think you all could agree that the cyan between your different printing technologies is slightly different. So the cyan on an HP printer is going to be different than a cyan on an Epson printer, which is going to be different from a cyan that's on, you know, an OSE type of printer or something of that sort, or a NERV. They're all going to have slightly different cyans. So just measuring it and quantifying by how much cyan is on the paper in terms of quantity is not going to help in terms of a color match. And that's why we want to use a spectrophotometer like the X-Rite EyeOne Pro 2. In the past, we've been able to communicate color just saying, oh, you know, if you actually have a density of 1.35, you should be able to get a good color match. And so people would dutifully measure their proofs and measure their output and try to mechanically get those to be the same. But again, the proofing system and the actual production printer are just so different in terms of hue that it just didn't work. And so this only really works when you're dealing with process lithographic type of printing, because densitometry is really geared for a particular type of color ink. It's not really geared for the type of uses outside of standard process colors. You know, it can't really differentiate between one cyan and a different cyan. It's really just kind of saying how much is there. And so that's why we need to use a spectrophotometer. A spectrophotometer is absolutely critical, as it is an important device in your business. And this is where it leads to the investment. There is an investment there, but you're going to get so much return on that investment by being able to have a better quality product and being able to control that product. Whereas if you don't make that investment, you're leaving your business to chance, where you're not sure if you're printing consistently or if you're able to do color matches consistently. And so as you see here, a spectrophotometer just really quantifies how much that color is in different portions of the rainbow. So in this picture that we have there in the middle, you see that there's quite a bit of energy in the yellow and green region, but there's very little energy in the magenta and the violet region. So it's a better description of what that particular color is that we can then use to adapt through LAB to find out what the correct CMYK build would be for your printing device. And it's agnostic, so we can derive density, we can derive RGB from it, we can derive CMYK, all through the ability of profile and using LAB. As I said, spectrophotometers are appropriate for grand format, where densitometers are really not. Here's a picture of the EyeOne Pro 2 with the I/O scanning table. And on there is a profiling chart. The way this works is that the arm moves out and it will scan from right to left or left to right each row and define what each of those color patches are using spectral information. If we were to use a densitometer, not only will we have to kind of do things manually in measuring each patch, we would only have particular information for each of those filters. So if I was measuring a magenta patch, it would report magenta readings. It's not going to report other readings unless I set up the densitometer otherwise. But that information that you're getting for densitometry isn't really appropriate, and it's not going to be very useful for us to kind of make decisions on if that's going to be a good color match or not. A spectrophotometer can be used to determine, you know, a reference point. So a lot of times we are presented with samples that were printed on various and sundry printing technologies at different places, and we're not quite sure what that color is. By using a spectrometer, we can actually really precisely define what that color is and be able to use that as a reference to now know how to match that going forward. A lot of times it can be, a printed sample, but sometimes it's actual product that comes in. So in this case, you can see that this gentleman's using an EyeOne to actually measure the color of a wine label. And so this is not unusual, and therefore, XRite has kind of come to provide some other solutions for non-print surfaces. The EyeOne Pro 2 requires that it be tethered in order to grab the data and bring it into a particular software. Another device from Pantone is called the Capture. Actually, it's Capture. I think I got the typo in there. And what this is a device that is portable and handheld that kind of does the same thing that we were talking about in just the previous slide of measuring objects that are print or non-print related. It's got a little video camera in it, so as you're getting close, you'll be able to see what area you're about to measure. And an interesting thing that it does that the EyeOne Pro 2 does not do is that it actually takes over 30 samples at different angles to get a really good representation of that color. Because if you think, some of these objects may have a little bit of tooth to them, meaning that there may be some texture. And so if the light source was coming in at 45 degrees, it may cast a shadow and therefore bias the results. This particular device takes it at multiple angles, and so therefore you get an average of those results. And the result, and what ends up is that it tells you like the closest Pantone color. It can tell you how close the Pantone color selected is to the reference, and it can even tell you an LAB value as well. So I find this is a very, very helpful, useful tool for CSRs that are trying to ascertain what the expectation is of that color to be printed out on the production printers. So in this screen capture, you can see that this gentleman measured a particular Pantone swatch, and you can see that it selected the correct corresponding Pantone swatch. Same device, a little different feature. It's more of an industrial type of device. It's called the RM200QC. As you see, it's very, very similar, same housing, but they just unlock some different things that provide more information for a printer and less for a designer, which is what the Capture is designed for. So here you can see that we're able to measure plastics and be able to get some recordings based upon that. So what about the RGB and CMYK files that we get? So, I mean, that's the bread and butter of every business, right? We get files all day long, and they come in various color models, and sometimes they're tagged with profiles, and sometimes they're not tagged with profiles. An RGB file, of course, if it's got equal values, is going to be a neutral. And, most of the time when those files come in, they're usually sRGB or Adobe RGB. Sometimes they are other models, but suffice to say that usually it's either sRGB or Adobe RGB. And, picking one of those two based upon your calibrated screen will give you a good reference point to convert to CMYK. If you're getting CMYK files come in, they're usually US web coded. If no one's done anything, or lately it could be Grackle 2006. So again, if someone does not tag the file, more than likely they've done a US web coded or Grackle 2006. But the easiest way to see this is on your calibrated monitor, open up the file, and then assign one of these profiles, and you'll get an instant preview to say, yep, that's what it should look like. I think that's what the customer was expecting. And now you know a point of reference of what you need to convert from, i.e. going from Grackle to your production profile, or from US web coded to your production profile. It's just, you need to have a point of reference. So that's why I'm suggesting that you assign your profile in Photoshop to determine that. But the US web coded, as you know, or may not, was not based upon G7. It was actually based upon a film-based contract proofing system back in the early 90s. well, not early 90s, but mid 90s, and has been used ever since. So it was never even based upon an actual press run because they couldn't get the presses to be stable. Now we have Grackle 2006, and as of recent, Grackle 2013, which are actually based upon press runs, the actual press runs, and the data massaged. So Grackle 2006 is by far a better reference to use these days. But if you get that US Web coded file, what happens if we were just to assign Grackle at our RIP? And so you see on the right-hand side, this is what the original separation looked like. And on the left-hand side, this is the same separation, but instead we apply the Grackle profile. I can see a difference. I hope you can see a difference on your screen, but it's very subtle. It's not a dramatic thing. I think it would give a very pleasing result if you were to assign the Grackle and print that. But if you wanted to get the US Web coded to look like Grackle, you would have to do a conversion. But this is just to show you what would happen if you did not convert it, if you just assign it. And as you can see, you get a pretty good looking print, even if you just assign Grackle without converting it. So here's a blow up of that section. And again, you can see maybe in the skin tone, a little bit of a change there. It looks a little heavier to my eye on the Grackle. But colorimetrically or the color balance is very, very similar. It looks like maybe the little red robot there has a little bit more red to him than he does in the US Web coded. Again, this is just a very subtle thing. So in ICC profiles, they're usually RGB or CMYK. So, your monitor profiles RGB, your working space for RGB files, you've got CMYK output devices that are based on, using ICC profiles. But what we have also available to us that is not discussed as much is something called a ViceLink profile. And what this is just merely a way that you're able to take two profiles and kind of smash them together to get a baked or hard-coded type of transform. Usually they're used in kind of a CMYK to CMYK setup, meaning, hey, I want you to convert from, like, let's say a source of Grackle to my production output profile. But it could be an RGB to CMYK, and it could actually even be an RGB to CMYK to CMYK. So all of this is just a way to take a bunch of profiles and string them together to come up with one baked profile. And the best part of this is that you're not going through labs. So you're not saying, hey, here's a CMYK build. What is that in lab? Show me the new CMYK build. And what this means is that it just basically is a direct correlation. So I've got one number set on my input. That means you're going to have a different number set on the output, but no translating through a 3-color space of LAB. It goes 4-color to 4-color. And because it's all already been processed, it's usually the quickest. So you may find that you get an improvement of rip speed because it's not having to do the color conversion for every single object and doing the processing on that. You also find that with device link profiles, you can do some scaling, meaning going from a larger color gamut to a smaller color gamut, a little smoother, a little better than if you just use profiles. It's something that you wouldn't see on every image, but on certain images with a lot of coverage, sometimes you will see a little smoother blending happening there, whereas with a traditional, you may see a little bit of posterization. It really is subject dependent, so it's not like it would rear its head on every single image that you use. So there are a bunch of different packages out there to create device links. X-Rite makes a product called the EyeOne Profiler that now includes device link. We're going to get into that in 2 seconds here. But there are other products out there that allow you to create device links as well. So when you're selecting a device link option, you have the ability of how you want to do that translation. If you want to do it as relative or perceptual, or if you want to do black point. But some of the other features that you can't do with a traditional traditional ICC profile conversion is specify the purity of color. So you can say, oh, like if I have a color that's specced out as blue, I don't want you to color manage it. I want you to force that to be the blue on the printer. So it's kind of like you can build in little exceptions there of how you want to deal with particular colors and making sure that they come out as vibrant and don't start losing saturation. This is a nice little trick to use if you struggle with reds sometimes. So if you find that your reds are always coming out a little weak, here's a way that you can build a ViceLink profile and specify how you want that red to be mapped so you don't get that gamma compression. The other thing you can do with the ViceLink software is you can make sure that the separation from the original is maintained to the output, and that's what we call black preservation. Or you can say, I want to generate a whole new separation because I need to drop ink coverage. In the process of using the ViceLink, you'll find that drop shadows and black text don't have a conversion to becoming a rich black, which sometimes if in really bad scenarios where you have registration issues, you'll see problems with the rich black not lining up perfectly. So by using a device link, you can ensure that those drop shadows and those texts are not color banished and that they are just passed through and maintain their integrity on the black slate. So in version 1.5 of X-Rite EyeOne Profiler, they added the ViceLink profiling capabilities. This was available in the prior products, which is Monaco Profiler and Gray Beth Profile Maker, but it took a little bit of time to reintroduce those back in to the X-Rite EyeOne Profiler. It allows you to make CMYK device links, so it does not allow you to make RGB to CMYK device links at this point, but that's not a huge problem for most people. Most people just really need CMYK to CMYK. The quality of the device link is really related to the quality of the profiles. Garbage in, garbage out. So if the profile that you're trying to use as your source is questionable, it's really not going to give you the benefit that you need. And so you may consider finding a better reference or creating your own reference. In most proofing workflows where they're using device links, they're using it with an absolute colorimetric rendering, which basically says, hey, I want to see the color of my source profile, which in this case could be Grackle. I want to see what that paper color looks like now on my bright white stock on my proofing paper. So show me that paper color so I know how that affects the surrounding colors. So put a tint in there. But in production printing, you don't want that tint. So you probably will be using a relative colorimetric, which basically says, hey, take the white of my source and make sure that it appears white on my destination. As I like to say, make white look white. It's what you would intuitively expect when you're making prints. But you're able to use black point compensation when you build the ViceLink, and that's helpful because sometimes the RIP software that you're using, even though it may have relative colorimetric available for a regular ICC profile conversion, it may not have black point compensation available as you're doing that conversion. And just a reminder, what black point compensation is just a way to map whatever the source black level is to the printable black in your destination. So scale that black to be now printable black. Without black point compensation, what sometimes can happen, depending upon the subject matter in the image, you could get compression of shadow detail because it's not being mapped up to the first printable black of the production printer. So here's a screen capture of EyeOne Profiler's device link settings. So you see here that I've decided to use the destination profile for its black generation. I'm using a medium size, and I decided to use relative colorimetric with a black point compensation. These are all the defaults. There are obviously other options in there, but just to make things simple, I just kept it that way. If we needed to do any ink coverage reduction, we could actually build that into the device link as well. In this example, I've clicked on the blue which is kind of like the gray box in the middle, right next to the red and green. And I've told it that I want to preserve the blue. I'm going to color manage the solid because I want to make sure that that solid color comes out the correct hue. But then I'm going to feather it. I'm going to feather it based upon the lightness, which is says to extend the tone range, and also the hue range, which is extend the color range. So I'm saying from 100% blue, right, that I want to kind of feather out that type of adjustment so it's not a hard break there. And so I just put in some random numbers of 15 and 20%. And I would basically start testing from there to see, okay, let's build a gradient, see what happens, and then start messing with these settings to see what gives us the best results for that blue. And by the way, sorry there, you can do this independent for each overprint and each color. So you see we have black, cyan, magenta, yellow, red, green, and blue. So each one we can affect or not affect within the device link. So here's how a standard profile conversion works. You've got CMYK in the start. You're going to map through a 3-color space called lab, and then you're going to come out as CMYK. So in this instance, any drop shadows, any black text is going to be converted to a rich black. You won't have the ability of maintaining that as 100% black. When you have a device link, you can see it just goes CMYK in and CMYK out. Just skips that step right there and goes directly to CMYK because it's already been pre-calculated. There's nothing that needs to be done. It just says, hey, when I got this CMYK build that shows up on the input, I know what the CMYK numbers need to be on the output. Most of the leading production rips out there in support device link, they're not advertising it heavily, saying, yes, we support device link.
Dan, for some reason, your voice has gone away. Not sure if what can we do, but your voice is completely gone currently. Since we're currently having a couple of problems, I have taken the lead in this moment. Dan, if you want to try to, again, I'm gonna give you the lead, but it seems that you do not have any audio connection for some reason. It's showing me currently in the system. I'm not sure if there's anything that we can do at this point. Otherwise, I would say if you can quickly disconnect and reconnect, we can surely go there. Jorge, Diego, and Rodrigo, we apologize. I'm sure that this is going to be just shortly. Dan just went off, and he's going currently coming through again. So we'll see where we are.
I'm back.
Yes, Dan, thank you for coming back. Now we're listening to you perfectly.
All right, sorry about that, folks. And some technical difficulty there. I was starting to say that the leading RIPs like EFI, Caldera do have support for device links, and but they don't advertise it as such. They don't make it widely available, and I think it's because they don't have a lot of solutions for creating device links. So you may see that change in the coming marketing for those products. When you create a device link profile, you're actually going to be loading it up as an input profile. It's a little bit unusual because you would think that you would be loading up for an output profile, but no, you're actually going to be loading that up as an input profile. And so this typically would be kind of converting your file from, like, let's say Grackle to your production output profile. That same output profile could be still loaded up on the RIP, and that would be used for spot color matching. So because spot colors are not really handled by device link unless they're process builds, and then they would be running through the device link. If they're a named color, it still will need to be color managed, and that's why you would still have the output profile loaded up. So the output profile in your RIP and the output profile in the device link that you created should be the same. And of course, you would need that too if you were going to decide to do a late binding workflow where you converge your RGB objects to CMYK. You wouldn't be using that device link, you'd be using your regular ICC profiles. So, how good is it? I mean, is it okay? I don't know. How does anyone define this? So, the International Standards Organization, ISO, has a couple different technical documents out there. Some are more applicable to traditional sheet-fed commercial printing and web printing than a grand format, but I'm going to kind of just discuss some of the dash revisions that they have here. So there's ISO 12647. Dash 2 is the more popular one, which is designed for offset sheet-fed type of printing. But type dash 8 kind of tries to start to address this, but it's really not so much for production printing per se, as more of kind of like lower quality type of laser printers and toner printers. So that's what 12674-8 provides. The 1267-7 is designed for validating proofs. So if you're going to be making contract proofs, how good does those proofs need to be? And, you know, production printing is really not that far different from just making proofs, because you're really trying to take the file that you're doing and somewhat proof it on your production printer. So the metrics that they outlined for 12647-7 are not bad to be using for your production printer. You may want to make them a little bit looser to allow for a little more variability that happens with your production printer, but I think it's a good place to start defining if we're having consistency on our printing. So in these documents, you can go and find them easily by just Googling ISO 12647-7. You can find out what the metrics are to achieve proofs that pass that. What you'll see is, though, that you'll have a lot tighter control of your colors, so therefore you have less unexpected results and less waste from customers responding that they feel that that color that you provided on this print campaign doesn't match the color on the past campaign. Because you'll have the ability now to, instead of subjectively, objectively show the customer and say, you know, we are printing exactly the same way, and that I can prove to you. I have some data to back up the statement that shows that the color matches that we did 3 months ago and the color matches that we're providing today are exactly identical. So And that helps in defining what you feel to be acceptable printing and unacceptable printing. What's going to be acceptable for that client and what's going to be unacceptable. So you don't waste time printing jobs that you know won't pass, and instead be spending time trying to get your printer to be as tightly controlled as possible, so therefore you minimize your rejects. In the past, a lot of people have seen this Idea Alliance color bar. It's got 54 patches. It's on a lot of different test forms. But recently, they've updated this to now include 84 patches. So it's quite a bit larger. It has much more expansion in some of the colors. And as I think I calculated, it's actually over 50% increase in the number of patches available. So if you have your glasses on, you may notice that in small little text, you'll see the number breakdown for each of the color patches. On the top, it's for the top row, and on the bottom, you see there's 2 rows that correspond to the 2 rows of 2 bottom rows of that 3 row color bar. But it ain't the eyes, ain't the Faux Grown. It doesn't look the same. It kind of looks similar, but it's not. You know, so don't confuse that the new one was just like a rip-off of the Faux Grown. It's quite a bit different. They did, you know, tip of the hat, take a look at what they were using there and try to incorporate some of that stuff. But we decided here that we had to change it a little bit differently, and they've actually expanded the number of patches, as you can see, from 72 to 84. So there's more patches in the Idea Alliance. There are different patches. There are some patches that are the same, but you'll notice that they are different. So the newest one, that's got the 3 row patch here, is not supported by a lot of RIPs yet. There are only a couple that support it. XRite does not support the EyeOne Profiler in version 1.5 as of yet. That will be something that comes in the future. But it is you know, something that I would consider including in all my print jobs, so at least I can start collecting data as to how consistent my printing is. So we've come to the end here. I invite you folks to post some questions on the sidebar on the right. I'm offering a free audit of your color matching system at your shop. If this is of interest, you can send an email to sales@rpimaging.com with the subject line Comm Color Webinar, and we'll respond back with the details of the audit. So at this point, Paula, I'll turn it back to you, and you can tell me if there's any questions that have been posted.
Thank you, Dan, for the presentation. I'm not sure. We have currently no questions, actually. I've sent you all through the chat. Also, if you want to have the free audit, as Dan mentioned, you can contact them through sales at RPimaging.com, and the subject line is Comm Color Webinar. And I just see that there's a question, Dan. And the question is, what about ISO 15311?
What about ISO 15? What was it?
15311.
I'm not familiar with that particular ISO document.
Jorge, can you maybe describe on what does it base the ISO 15311? Maybe you name it as you know, this is the specific number, but maybe Dan knows it as something else. That way we have more clarification on it.
There's quite a number of ISO documents out there that are for the printing industry, and you know, the good thing is that they're constantly evolving, they're constantly getting input, but it's a long process. It's a very long process to get these things ratified, and a lot of them are perpetually in draft mode, if you will, meaning that they're still being worked out and not published.
I think that's currently it, Dan. We do not have any other questions or anything specifically. What we will do is, probably I will try to find out a little bit more about this ISO 15311, Dan, and I'll get back to you on that. Thank you very much, everybody, for participating in the webinar. As I mentioned, the webinar has been recorded. We will be putting it on our Vimeo channel, as well as the other two actually webinars that we had on the past months of March and April, so that you can see the complete webinar series. Thank you, Dan, again, and have a great week. Goodbye.
Thank you, everyone.